So we'll start off real quick with the creating of a new program, and then just kind of throwing some positions in there real quick. So to like get to where your programs are located at, you hit the select button. And so from here you can see programs. To go ahead and just create a new program, you hit create, and then you can just give it a custom name. There's some names that you can use down here at the bottom, like style, program, alt, job, whatever. And there, so this says words. Notice if you scroll down here, this changes to letters, and you can like manually punch it in. On older robots, that's the only option you have. On the newer robots, now you can do this options thing. But yeah, there should be an option for a keyboard here, and then it'll bring up a digital keyboard where you can then plug in the information. So I'm just gonna choose a generic name for right now to start this program. Job, enter. And also too, like it's very good practice to always have like a job number. Oh, I could have done it like this actually. So I'm gonna hit previous. I'll sit in the previous key to go back, and then kind of go, you can navigate with your cursor. In Roboguide, we're using the arrow keypad, but on the Teach Minute you can do the same here as well with this arrow keypad. One advantage to like utilizing Roboguide is you can use your keyboard for some of your functionality. Like actually, if I'm not mistaken, I can, like if I want to call this job 1, yeah, so I can just press the number key on my keyboard to be able to use numbers and letters. Maybe that's why it's not giving me the keyboard option. But so we call this thing job 1. This is good practice to give thing a job number, so that way at least there's some type of segregation, and you can keep using the same word job 1, job 2, job 3. Jobs are also utilized in program selection, right? So this is model number 1 of the part, this is model number 2 of the part, model number 3 of the part. Or jobs can also be used like this is process number 1, this is process number 2, this is process number 3. And so each one of those things are called as a job. But depending on like what sector of what industries you work in, this might be called something different. It might be program number 1, program number 2, program number 3, or recipe number 1, recipe number 2, recipe number 3. You'll just kind of see just some different programming conventions. So if you see something like that, that's probably what you're looking at. You're looking at different model numbers of a part being ran, or different processes inside of an operation. Enter, enter, end. All right, so now we have our first program that's officially here. I'll kind of just run through and create some points. Whenever creating a point, you have different point options. Also, depending on what type of robot you have, you may see other options that are here for like, for example, for welding robots, they have a package in them which will give you a C type of weld, a circle weld, or an arc weld. These different points will change the way the robot moves. So with the J, that stands for a joint position. With an L, that stands for a linear position. Okay, so one thing a joint position will do, a joint position will get to a point as fast as the robot can get to the point. And so the robot doesn't care how it gets to the point. A linear point, the robot will move in a perfectly straight line to that point. So a perfect example of this is like if you had this here, and let's say for instance this was the robot would need to move from this point right here to this point right here. Robot moves from this point to this point. A linear move, the robot will move directly along this line to get to that point. A joint move will move like this. Because it's faster for the robot to move all of its joints in like that arcing motion to get to this point than it is to move in a linear motion to get to that point. So one important thing to keep in mind when going to using a joint position versus a linear position is a joint position could potentially cause a crash. And when I say that is like, let's pretend you had a pillar right here, right? If there's a pillar right here, well, if you record in a linear position, you're just gonna slide right past, and kind of don't have two hands, but you're gonna slide just in this one direction right here, right? So you don't have to worry about the robot traveling anywhere. But if you're doing a joint move, it'll come out here a little bit. The next big thing to keep in mind is when you're doing a joint move, the arcing will be larger based on the speed of the robot. So the faster you move the robot, the bigger the arc will be. So if you said robot move at 10% speed, I'll put the bottle down. At 10% speed, maybe the robot just arcs like this. And maybe it looks very linear. It doesn't even look like it'll just kind of travel over here. But you bump it up to 50%, and it's gonna go like this. You bump it up to 75%, it's gonna go like this. You bump it up to 100%, it's gonna go like this. Joint speed, it will go from this point to this point as quick as it can. So a point being with this, and the reason why this is super important is because, let's say for instance you wrote a program, you ran the program at 10% speed, and you're like, yeah, everything's good. Then you go and you run it at 100% speed and it just plows through something. Because you're like, oh wow, like, because like it increased the arc of its movement, and so now its pathing is different. Also, stop distances will change as well. Stop distances meaning when you're traveling from here to here, what is the speed of its deceleration, right? So it'll decelerate at different rates. And another big part of this that will be different is look at the continuous 100 versus a fine. So continuous 100 means, let's say for instance, we'll go back to I have 2 points here, or 3 points now. I have 3 points, 1, 2, 3. If this point is a continuous 100, the robot will go through, will arc around, okay? If you say fine, the robot will go exactly to that point and then exactly to the next fine point. So fine points, the robot will stop at that exact position, that exact point in space, down to the millimeter, less than a millimeter. So you generally use that on a pickup or on a drop-off. That's when you need a fine position. Pick up and a drop off, especially if you're picking up things that are precise. Like this type of robot cell here, where you have a metal tool, picking up a metal part, you want that to be a fine movement, right? But if you have a vacuum tool that's picking up a bag, and the bag has squishiness to it, and it's okay to push into it a little bit, you don't need that to be a fine position because the robot can over travel a little bit and it's not gonna hurt anything. But whenever you're going like metal to metal, you need to make sure that you're using fine positions. Also, out in space, that's when you'll use like your continuous 100. So if I'm just trying to get from my pickup position to my place position, all these positions out here in space can all just be continuouses. And maybe if you get close to like a pillar or something, like you have to move around like some like beam or fencing or something along those lines, at that point you'll want to reduce this continuous. So I'll just select that one, a joint. And you can change this continuous here to like a continuous 25. That'll change how much arch it allows. And you can, since you're going from 100 to 25, you can kind of easily consider this that you're going like now 75% less of a curve than you are at 100, because now you're at 25. And if you take a continuous down to a 0, this is actually the equivalent of a fine move. So a continuous 0. So I personally don't use fine moves very often. I'll put something to a continuous 0. And they say continuous 0 is actually more fine than fine. It goes to even more of an exact position because it'll go there and it'll kind of like sit and make sure it's at that position, and then it'll go to the next thing. But one other reason to use a fine versus a continuous 0 is a lot of times a fine will indicate what we call approach position. So what is approach position and what is a depart position? So an approach position or the at position. So the at position means like at the part. So right now we are at the at position of this part. At position, also known as the pickup position. Okay, so like whenever you go here and then you go down, so this would be the approach position or the above position. Visibility. So this is why you have things visible and invisible, and you can turn on and off different things. So now we just have the fixturing, and I don't have all that fencing out here in my way. Also, Roboguide will respond faster. The more stuff you have inside a Roboguide, the more lag and delay there'll be. So going and looking at this, according to this fixturing, we're actually not at the at position. So we're going back to position now. Right now we're actually at the above position or the approach position. So if you're gonna use or be doing an approach position, this approach position should be a linear position. So from here, I'll show you how you can change from a joint to a linear. And you also seen there was the circular option. So this robot is equipped with the circular option, linear. So you need to be over top of either the linear or the joint, the L or the J, and then you hit the choice button down here. To go into like some more features that are there, and we'll get into this in a second. But now hovering over the 1, this gives you different options. Now you can choose between a position and a position register. We'll have to stay tuned for the position and position register thing. This would probably be set as a position register and not a position, and we'll get into that in the later section of the video. then position. So now we're looking at the physical position this is recorded at in space. So like what user frame we're using, what user tool we're using is right here. User frame 0, user tool 1. Most of the time you'll almost always have like a user frame number. So like this frame number would be accordance with this fixture here. So if ever anybody wanted to move this fixturing, they would reteach the user frame, and then all the positions would follow. They wouldn't have to reteach every single position. Because for example, this tooling here has at least like 9 positions in it that are taught. So we'll add another point. So we'll also make this a linear point, and also find. Again, these find positions are what kind of will help you define. So when you're reading through a program and then you see find positions, you should know that the robot is handing something. It's either approach position or it's an at position. So now one thing I want to point out here is, see we have 2 at positions. The reason why is I just recorded both these positions at the same position. So the robot is physically at these positions. So I'm going to click position. And so what we need to do is modify the Z. So like, let's say first I want to alter this position to be the pickup position. Okay, so I'm going to come in here and I'm going to look at, by the way, I'm using the right clicker and the scroll wheel. So scroll wheel gives you the pan to move back side to side, and the right clicker gives you the ability to rotate. So that just helps you kind of like move around in Roboguide a little bit. So I'm trying to analyze how far I am from here to where my pickup position is here. So maybe it's like 200 mm or something like that. Now, in the real world, you definitely don't want to overshoot, because an overshoot could be a crash condition, and also you need to manually test it anyway. So let's say, for instance, we're at negative like 148. So these are just rough numbers for right now. So let's just say negative 300. So I'm adding to the negative. So we just went negative 150 more roughly. Okay, so negative 150 more will then drop us down lower. So I'll just say done. And so now you can see we're not at the same position anymore. We're at this position, but we're not at this new one because I modified the position. So now that position in space has moved down. Actually, matter of fact, to perfectly call that out, since we're in this program and we're in Roboguide, this is like an advantage also of Roboguide. Notice like I'm navigating Roboguide, just going back and forth between the right clicker and the scroll wheel click to make it, so that way I can like get to exactly where I want to look at. So like whenever you're doing these type of things, like you have to dig in, look deep, and study what you're seeing, you know? So like you're gonna have to move this thing around and see exactly. So I can kind of look at this and see that like it's a little bit lower than what it needs to be. And that's basically what I'm analyzing. So this is that second position. It looks a little bit lower than what it should be. It also looks like the robot is not currently over the appropriate position. And so you can see right here, P1, P2. P1, P2. So so nice advantage of Roboguide. You don't really get this in the real robot. You might be able to see this in some of the newer robots have like 4D, and you might be able to look up and see these inside the 4D viewer. Yeah, so like you just advised, we're probably too far down, so we'll say negative 275 instead of negative 300. So we removed a little bit of that. Now, so when we say done, you should modify that position and brought it up just a little bit. And it probably did. So whenever we went from 300, we're talking in millimeters. So roughly a good rule of thumb is 25 millimeters is an inch. Yeah, so you might have some teach pendant things that are a little bit different, because like this step button is over here versus a lot of times the step button is over here. So some of your buttons might be in a different position. So shift, step. So you can see up here in the top, these are your indicators, whether you're in step mode or not. So you can see it toggling at the top there. So we want to be in step mode, because if not, it's going to just run through the program. So I just put in step mode, I jogged the robot down, and now we can kind of look at where the robot's position. So I would say like the word for this is I just forwarded through the program. I forwarded through the program and I tested the position that I just wrote. So now I'm just looking at that. I need to be over here. So this position is completely off from where I actually need to be. You know, I can go ahead and go in here real quick and mess around with this position. By the way, notice This is really just a Roboguide issue, but like, see how I'm clicking my cursor around and it's going to the beginning and the end? It's because the shift key's held down. You'll make this mistake like 1,000 times. But yeah, so I turn that off and then I can go here. I'll go to position again. And then I need to zoom out from the robot to see where the base of the robot is. So once you know the base of the robot, then you know your X, Y, Z, if this is in world frame. So if we're in world frame, the robot's facing me, or facing us, however you're looking at this, but which means X is facing towards me. And then Y is facing away from this fixturing. So Y positive is this direction, X is this direction, and then obviously Z positive there. So the reason for that is now, like, I notice the robot is off in this direction here. So I know that if this is a positive and I need to go over some more, I'll zoom in again. I'll see like, okay, like how many millimeters do you think this is? Maybe 50 or 75 millimeters, okay? So going with my right hand rule, that means positive is this way. So I need to go in the negative direction towards the part. So with that being said, if I need to go to the negative direction, let's say 75 millimeters, I'll just also say with rough positioning, this is negative 1950. Obviously, like your final programming, like you'll fine tune this and might have to get it down to some closer millimeters. Just kind of depends on what operation you have. Some operations it doesn't really matter. I'm glad that just happened. This is something that a lot of people will make this mistake, and be very, very careful to not make this mistake because it can cause some major issues. But the mistake is, I basically just exited it out. I didn't say done. So if I just say next or select or any other button, if I don't press this done button, it won't confirm the changes that I just made. Which means if I don't press the done button, I think I made the changes, I didn't make the changes, and first of all, I'll be confused. Secondly, if it was something to avoid some type of crash, well, now you're gonna crash because, you know, you didn't make the change you thought you was gonna make. So we'll say done. Notice I'm not at any of the positions now because I modified this position and we're not actually at that position. So again, we'll do the exact same process, shift forward. In the real world, this would create a crash. So this tool right here, this purple piece, would crash into this part. So you'd have to jog the robot up and then you'd have to move the robot, or you wouldn't necessarily have to move the robot over, but you have to at least jog the robot up before forwarding. Now I don't care because it's simulation software, so I can run right into the part if I want. So shift forward. Okay, this is another one that'll really help with any type of program things. Function 1, abort all. So abort all basically means abandon what you was doing in a program because the program will lock onto particular positions. So since I already forwarded to this position before, so going back into the shift forward, I'm gonna shift forward. It came over here, a little bit too far. In Roboguide, you can also use the shift key to turn on and off the shift. And also too, one thing that's really nice is see how the shift key, when I hold the shift key, it holds the shift button. So you don't accidentally leave it on. So that's kind of nice. So shift forward, I'm already at that position. I need to modify that position again. Position, modify. So I went too much, so we'll just say like negative 1925. So I just went from negative 1950 to negative 25. I gotta hit the done button, make sure to hit the done button. And then we're not at the position. And I already know just from experience, I need to go function 1, abort all, because it's gonna do the same thing and not let me go to that position if I don't do that first. So I can click the shift button here, or I can click the shift button on my keyboard and then go forward. Boom, now we're at the position. That position looks fairly appropriate. We're still not at the position 100% because we're not inside the part. This little purple ring should be inside this part. One thing to keep in mind is now that we modified all these things right here, our approach position is not in the appropriate position because we recorded it up here when everything was off. So the Z height of it doesn't really matter, but we changed the Y direction. So this is another use case where doing direct entry, this is also what this is called. So when I click position and I manually punch these in, we call that direct entry. So So negative 1925. I'll take that number. I hit the escape button. I don't need to do anything there, but now I'm gonna go up to here. I'm gonna go inside this position, and I'm gonna give it that same negative 1925. Enter. Done. And also, it's good practice to do this as well. Hit position again, and look at your number and make sure it's there. That verifies that I hit the done button. You're as a human confirming that this process or this data was taken into the robot. There may be some weird instances where you do hit done and it's still, for some reason, the data didn't go to the robot. This is almost like a never type of chance, but you just never know. Okay, so boom, boom, boom. So now we can zoom out. You may not be able to see it, but that position is directly above now because it has the same Y direction. The X and the Y match. So whenever you do an approach position, your X and your Y need to match your at position. And the reason for that is you want your robot to come directly down. This is when you're moving in a downward motion too, right? So when moving down, your X and Y need to be in the same positions because you want to move down in an exactly straight line. There's approach positions. I want to add this caveat to this. If your approach position is inside of something, like so if you're going this way, so your approach is here and then your at position's inside, then you need to make sure like your Y and your Z are the exact same. So you got to think about relative to which way you're going. Same, we'll use Y as another example. Let's say for some odd reason you need to go into the Y direction. You need to make sure that your X and your Z data is the same. That way you still move in a straight line in Y. And so just this verification, the only thing you do is you just open up your positions. You say, what is my X? It's 758. My Y is negative 1925. And then you just come down to your other position, 758, negative 1925. So now you've confirmed those those positions that they're directly above each other. One last thing to kind of touch on with positions, speeds. Just keep in mind, like this is where you can change your speeds. Whenever doing a linear movement, these will be millimeters per second. And whenever doing a joint movement, they'll be in percentage. They'll just be in a percentage. So is it running at 10% speed, 50% speed? And I'll just switch that real quick. Joint. Switch this position to a joint. So now see how it's fine, or it's a joint position now. And then your speed is 100%.
Gotcha.
So the equivalent linear speed that's 100%, I believe is 2000. So like if I try to put it in 2200, it'll say you can't do that. Yeah, invalid integer. You have to choose a number between 1 and 2000. So 2000 millimeters per second is the fastest that you can go. Also, there's also choices to change it, inches per minute, degrees per second, things like that. But every program that I've ever worked in has always been millimeters per second, and there's really not a reason to change it. So in this video, we'll go through writing of a program and some of the programming structures and whatnot. Here we've created a couple points. However, like points are kind of like one of the most basic parts of a program. So to do a little bit of program editing, a few things that we'll do here and a few things that I kind of always do whenever I do programs. We'll come over here, we'll hit these like next button. You can use the next button down here on a regular teach pendant. So you're gonna go to this EDCMD, which stands for edit command. We're gonna use the insert function. Notice you have like delete, copy, find, replace. You can do some other functionality there. So we'll do insert. How many lines do you want to insert? I always like to create a nice gap. So I'm gonna say 5 lines, enter. So I just created 5 lines. Also, I don't like the points of the program to be congested by on the bottom side either. So I'll also do edit command, insert, 5 lines. Just because I just like having the space to be able to do stuff. Because if like this, now I can add instructions here, I can add instructions here, you know. And another programming practice that's good to do is leave lines open. So like if these are my approach positions, maybe I would do like this and I would add a comment. I'll just go ahead and add a comment just to show you that. So I need to switch this to instruction. Your instruction button might be in a different location based on your teach pendant that you have. So we'll go instruction, and then we'll go to comment with, I believe it's miscellaneous. So we're in the miscellaneous statements, and then we'll go, I believe it's remark. So now we have a remark here, hit enter. So I created a remark right here, which the remark is the comment. So from here, I'll hit enter. And so you can manually punch in. A lot of the old robots, this is how you had to do it, was the only way to do it. This is like the old cell phone method of like punching in a name for something. So we would call this like, I'm just gonna abbreviate this and we'll just say pick. Right, and when I say pick, it means pick position, right? And you might see this, people will shorthand program something like this, where they'll say pick, and then you'll see something that says place, or you may see something that says approach, right? So I'll just call a pick, and then we have our approach and our pick position in this same program. So all this did was give us a comment. This has no functionality to it other than for the human to be able to read something. That way, whenever you come through here and you're reading this program, you're not just looking at points and just trying to have to guess what every single thing is. So commenting is very important for being like a good programmer. There's a lot of people out there that don't do a good job at this, and it makes it hard for like the next guy who comes along who has to program on their system. So like really commenting your logic and writing your logic where it's spaced out nicely and very organized is one of the things that really differentiates a good programmer from a not good programmer. So now we'll go into just some other type of instruction things. I don't have really anything exactly in mind, but I'll add one of the first things that you kind of learn in every single program, which will be your jump and your label, okay? So this gives you the ability to loop and move around within a program. And we'll go through this explanation as I add these things. So I'll put label at the top. I always put, so this would be considered like the main loop for our example right now. So while doing a main loop, I always use the number 10 because it's not the very beginning of the program, but it's at the top of the program. And I'll give you an example of that here in a second. Maybe, and I will add here in a few minutes, I'll add some more instructions up here, right? And that's why this is a label 10, because there are gonna be some things above the label 10, but there won't be many things above the label 10. I'll just put a couple things above the label 10. Maybe we have to do some things before the program runs. Maybe we need to open the gripper. We need to make sure the gripper's open. So you'll always like do things like that to make sure the gripper's open, because you don't wanna ever go down to a position, your gripper's closed, and you just smash into whatever you're gonna do. So we call these like a knit type of things. A knit means to initiate, or to get into a good starting position. So we have a label there. I'll do instruction. I'll go back to the jump label thing again. And then we'll do this one as a jump label. Okay, we're also gonna name this one 10. At this point in time, what we've created here is an infinite loop. Meaning, as soon as the code runs, and it passes this label 10, it will always run in a loop right here. And what do I mean by that? Oh, we'll just do it through the brief example. So I'm in step mode, so that way you guys can watch this program run. I'll say shift forward. It says, do you want to start from this line? I actually don't. I'm gonna let it take me back to the top of the program. So I'll say no. It brought me to the top of the program. And I'm gonna slowly forward through this program in step mode so you can walk, so you can see the code execute. So here, so another robot's gonna move to that position. Robot's gonna move to the next position. Also, one thing that I left out in the other video is we didn't do a away from position, which an away from is generally a repeat of your approach position. So whenever you go down to something, you need to go back up to something at the exact same position. So in that instance, like I could just like copy this, like I can actually do like this point. So notice I just created another point where I'm currently at in space. Now watch this. I'm gonna change this to a 1. So I'm gonna change this 3 right here to a 1. Boom. Now, these two positions here are exactly identical with one another. Position 1 and position 1 are the same position. I'm gonna change this back to linear too, because it should be linear. Does that make sense? So instead of me creating a third position that is the same values as this other position, I just said make them the same position. So that way, if I modify this, like if I do a direct entry right now, it'll modify both the positions, or it'll modify both of these. The reason why it's set up like this is because you actually probably want it set up like this way, because this speed is when you're going to that position. So when you go to the above position, you can go fast, right? And then you're gonna go down. You're gonna go down slower at 100 millimeters a second. And then whenever you go up, you're also leaving that fixturing and everything still. So you wanna go up kind of slow, at least till you've cleared everything, and then you can, then you can retract more quickly. Okay, going back to the execution of this program itself, forward, do you wanna start? I'm gonna say no. When I say no, it's gonna take me back to where I was at in the program. So that's where it took me, okay? I was already there, and we'll run through this again. So I'm just forwarding, boom. Jump to label 10, it jumped to the label 10. Okay? I'm gonna run through it again. So we're at the above position. We're at the position. Now we're back at the above position again. Okay? Again, running through the code, jump to label 10. We jump to the label 10. So whenever you guys were executing your programs before, it would always get to the end and it would just stop. And then you wouldn't do nothing else. You had to go start back over at the top again. But this automatically takes you back to the top. So that way when the robot's in auto, it's performing that motion over and over and over again. So this is one of the first things that kind of you'll learn is just a jump to label and label. Boom, very simple. There's not any decision making going on here. And what I mean by decision making is there's no if anything. It's gonna get to this line, it's gonna execute the thing, right? Now, I'm gonna leave that jump there. I'm gonna create another instruction and give you an example of how something like this might work. So let's do an if statement. And let's say yes. Also, instead of deleting, I can also just write an instruction over top of it again. Do you want to delete the lines? I'm gonna say no. But you can just delete it if you want to just delete it. Shift button held down, no. So I can just write an instruction over top of it again. So go back to instruction, go back to the if statement. The thing that I want to call out here in this if statement, I almost never use any of these if statements here. I just use this bottom if statement. This bottom if statement, the significance of it is you build the if statement. Meaning I can make this bottom if statement be any of these if statements. But if I choose one of these if statements, I can't modify it after I choose it. So that's one thing I don't like about it. The second thing is too, and this is the most major reason why I use this bottom if statement. This bottom if statement will give you more executable items. So the list in which this gives you the ability to do will be less than the list of the things that this gives you to do. And hopefully I can show that in an example here. So I'll say if, let's say register, we'll use a register, and I'll just say register 1, maybe something's there or not, I don't know. So if register 1 is equal to a constant means a number. You then have to signify what that number is. So I'll say 5. Okay. Jump to label. I'll say 10. Okay. And I'm also gonna, again, I like the good programming practice here. Add a command, 1, insert 1. I want gaps between things. I don't want things on top of each other unless they're supposed to be on top of each other. If these are all on top of each other because they're a piece together of code. So also this will make this easier for me to demonstrate. So this makes a decision. This if statement makes a decision. So if register 1 is equal to 5, jump to label 10. So let's just run through the program and just see how it reacts. And by the way, this is like one of the best ways to like teach yourself how to program. Because if you can plug these things in and then you can run through the program and you'll see how it reacts. And then you'll say, well, why did it not do like the thing that I thought it was gonna do? And then from there you can kind of self-teach yourself and explore and then see like, oh, that's why I didn't do the thing, you know. Again, just move through the positions, bop, bop, bop. Now we're gonna go to this if statement. Now I'm about to execute this if statement. It did not jump to label 10, okay? Obviously this one's gonna jump to label 10 because there's no decision being made. Whenever you're choosing something here, for example, this register, so we have to explain a little bit of what a register is. So I'm gonna explain real quick what a register is real quick. So we're gonna click the data button. Data will take us to our registers. I do wanna call out, shift button. There are different types of registers. There's registers, position registers, Carol vars, Carol positions. Carol, almost nobody's really using anymore. Carol is from the older robots. Whenever you used to program robot in Carol, and there are Carol variables and stuff like that. I would almost just ignore these. I personally have never even programmed in Carol. I've read some code and shot some things in Carol, but like I've never even used Carol throughout my entire career. However, registers and position registers will be used very, very much. We're gonna go over just registers real quick, and then I'll touch on position registers, but we won't go deep into it. So for a register, only thing a register means is it means it's a place to save data, right? So going back to the program, register 1. So see how there's a register 1 there? If I go back to data, register 1. That means I want you to look at this piece of data, okay? And I want you to see what is it equal to. Register 1 is currently equal to 0. Now, I could either come in here and change this to whatever number I want, right? Now register 1 is equal to this number here. Yeah. So if would be what we would call like a logical statement, meaning we're gonna make a decision on something, right? So maybe is the part present? The reason why, yeah, and probably the reason why the dot is not being connected at this very moment is because you don't understand what a register is used for. So understanding what a register is used for will kind of take you to like, okay, now I get it, I think. So as of right now, I'm giving you a very generic example, and this is not how you would really use this. The only time you do what I'm doing right here, right now with this direct entry is for your own trial purposes, like I'm doing right now. So I want to see how this code's going to execute. So let me just run through the program a couple times, and then maybe that'll kind of show some things. So I just set the register 1 equal to 100, right? Shift forward. Okay, again, the robot does not do, or the code does not jump to label 10 in that if statement, because if register 1 equals 5, register 1 equals 100 right now. Very good. So we'll go back to data. We'll turn that into a 5. Go select, job. We'll run through it again. Run through our positions. Now we're gonna execute this piece of code. So it jumped to label 10. Okay, and notice it did not go to the bottom. It jumped to label 10 with, yeah, it didn't go to line 12. The if statement called for it to jump out of the program and go to label 10. So the if statement is the first part. This is the conditional part. If something, do something, right? So the things after the comment means to do this. If this, do this. So that's like a good, easy way to look at these different statements. Now, I'm gonna show you something practical, a little bit practical. It's still definitely a insert some lines here. Okay, and then I'm gonna say instruction, registers. Again, same with the registers. I really kind of like to just use these right here where I can build them myself. Because you can do more things. Like say for instance, like up here, like I can only do register equals register plus register, right? But with this down here, I can do plus this, plus this, plus this, plus this, plus this. So I can do a bunch of things in that if I want to. Versus again, like this, these just lock you into like only being able to perform whatever that function is. I know what I'm gonna do with this, so I'm automatically gonna choose that. Here's some position registers. So just notice these are kind of here. I definitely won't get into that now because it's like a further down the line thing with when we get into position registers. Choose a register. We'll go ahead and use the same register 1. We'll use register again. We'll use register 1. And then for the last one, we'll use a constant and we'll do it 1. Okay? Now I'm gonna go over to data. I'm gonna set our data to a 0. Okay? Back over to our program. Shift, forward. So I'll just forward through this program, okay? So go through. If statement doesn't execute because we're not at 5, we're at 0, okay? I'm gonna execute this logic. Register 1 is equal to register 1 plus 1. Okay, I executed that logic. Now I'm gonna go back over to data. Notice register 1 is equal to a 1 now. So that's what my math just did there. My math just took register 1, then it took register 1 again, and said add 1 to that. Do you want to start in a different position? No, I don't, because I just wanted to take me back to where it was at. Okay, jump to level 10. So we'll kind of just run through this a few times, and then we'll go look at the data. So I'm just running through the program. So like this is like what the 3rd time we just executed. So our data is at a 3. Okay. Select. Keep going. Okay, so our data should be at a 4 now. Data should be at a 5 now. Okay. Let's go look at our data, make sure. Our data is at a 5, just to confirm. Go back to here, shift forward, and it jumps up to label 10. So, basically what we did here is we used this as an increment. In the real world, where this similar thing might be used is maybe we're stacking something and we want to stack to a certain height. So in this instance, with the example of 5, maybe we want to stack something 5 parts high. And then we want to go on to the next thing. So you could do like this, and then have a jump that then takes you somewhere else. So also another thing to keep in mind is where this is located at will change in the program. Will change the program completely, right? So to give an example, if I go, let's copy. So if I go copy, move cursor to selected range, copy. For some reason it should have gave me a cut. It didn't give me cut. By the way, I just kind of went through those things. You don't really have to worry about that unless it's a position. So I'll go ahead, continuing where we left off. We just added this position or this if statement down here, and I'm also removing this if statement right here. Right, this is a pretty simple thing to look at and be able to tell what's going to happen. So from here, can you kind of tell what the code will do? Get down to line 14 and it's going to jump from line 14 up to line 3, and it's going to continue to do that infinitely. This number, the register value will continue to add up because it's inside the loop. However, you'll never get down to line 16 where you'll execute the if statement. So like to go into another example of something very similar to that. So we say copy, just copy that one thing. And then we'll come back up here at the top and say paste, logic. So now, honestly, since it was never gonna run this one anyway, it don't matter if you delete it or not. However, it's terrible like programming practice to not delete it. So you always wanna like delete stuff that you're not gonna use or you're done using or anything that's like dead logic. So now that I changed this if statement, so the if statement's now on line 4. We had it like on line like 14 or something at one point. So now that it's on line 4, and a lot of times this would be the more appropriate way to go about this. Meaning you would add the value at the end and then you would make the decision at the beginning. So a lot of times it's better to make your decision to do something prior to starting whatever the thing is you're gonna do. And part of that reasoning may be, I'll give you another example. We'll add some more code and kind of show why that might be a thing. Copy. This will be good. This will be a little bit confusing, but I think this example will be better. Okay, notice I pasted it and it pasted without positions. That's where, whenever you do paste, that option of what you paste matters. Because that paste option, they were just there a second ago. Instructions. Edit command again, edit command, so then copy, then paste. Logic, position ID, position. So when you say logic, that means I don't want any of the positional data there. That's why there's no positions inside of these positions. It's not a position right now. It's just a logical potential position, basically. And I think without editing these, your code won't run either. These have to either be deleted or a position added to them. Position ID would mean they would carry over that 1, 2, 3. So let me say 1, 2, 3. If I would have pasted position ID. But let's say, for instance, in this instance, we're not going to do that. Also, there's a next screen, so keep this in mind. You can paste reverse logic, which reverse logic is actually very good for positional stuff, because you can say like do this, do this, do this, copy that, paste it, and reverse it, and now it'll do all those things in the reverse function. And there's some other ones here too. You can like kind of play around with these. Sometimes I even forget what some of these do. Then I just have to use like whatever ones I think is the right one. I almost never use these just because I don't really have a major reason to use them. So we're gonna go ahead and give these a position ID. So I have 1, 2, 3 right here. So now let's use the next logical thing that makes sense, which would be like 3, 4. Okay. So we'll give this one a 3. Enter. We'll give this one a 4, enter, and we'll give this one a 3, enter. Notice they're following the same pattern, okay? Also, like good practice is like we use the lower number and then the higher number. We use the lower number and we use the higher number. Following as much repetition as possible, or as much, not repeatedness, but uniformity, maybe uniformity. As much uniformity that you can have, the better. So you want as much uniformity in your programs as possible, where things like align and they match. So that way somebody can come in here and they see, oh, okay, they're doing something there. Oh, they're doing like the same similar thing right here. With just looking at like the numbering of this. Like a good programmer can look in and see those type of things. Again, I'm gonna add a space because good programming practice. I don't like to see things, that register doesn't go with that one. Actually, I'm gonna add some more lines because what I'm gonna do, hopefully this doesn't end up being too much because I'm gonna add like a little bit to this. It shouldn't be too bad. I think you'll understand this. Edit command. Not edit command, instruction. So we're gonna go to instruction, jump to label, 10. So you can have multiple jump to labels. You can only have one label of the same number. So you can't have two label 10s. You can have as many jump to labels as you want. Now I'm going to put we're gonna do instruction. We're gonna do a jump to label. And we're gonna do a label, okay? Now, depending on like what I'm gonna do with this program, these label numbers are always indicators in any program that I ever write of where you're gonna jump, where you're gonna be at in the logic. So if it's a 50, it's in the middle of the logic. If it's like a 70, 80, or 90, it's towards the bottom of the logic. So you always know if something says jump to a label and then whatever number that it is indicating where in the program it's gonna jump to, whether it be beginning, middle, or end. And then like say for instance, I might have like 80, 81, 82, 83, and then you'll know like 81, 82, 83 will all be down in the program together, near to one another. And the label itself, the jump to labels can be all throughout the program as well. So I will call this one, this is still gonna remain pick. So what I'm gonna call this one, I'm gonna call that one pick 1, and I'm gonna call this one pick 2. So since this will be still a beginning level task, I might call this one, or this is a beginning of the program line of code. I will then make this like label 20 maybe. Sometimes I'll get split on like whether I should name this label 20 or if I should like name like label 11. You know, so there's some like discrepancy. So like a lot of times when writing code, like especially if you're writing an actual program, it's good to like lay things out on paper and then have an understanding of how you're gonna do your structure. Okay, I'm gonna have this many pick positions, I'm gonna have this many places, I'm gonna have this many things, da 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 da. And after you have all those things laid out in front of you, you'll kind of see like what can I put together in like its own little portions within the code. Enter. So the only thing I wanted to do here is I wanted to put a 2 on here, just as an indicator. Like this is gonna be pick 1, and this is gonna be pick 2. Also, like if I knew we was gonna have 2 pick positions in the beginning, I would have already labeled this one pick 1. But I didn't really have that forethought that this is what we were gonna do. So I don't know what positions these recorded. Hopefully the robot can reach these positions because I just changed the number and then the robot inserted whatever it inserted. So maybe it'll reach these positions, maybe it won't. Now, one thing I'm gonna do here is I'm gonna change this jump label. I'm gonna change it to jump to label 20. So as of right now, we do our data. I'll set this back to a 0. The register's at a 0. And then we'll go back to our program. If register 1 equals 5, jump to 20, okay? So basically we'll run through this. We'll run through these positions. We'll add in our register, and then we'll jump back up to label 10. Okay, I'll go ahead and just execute the code. Yes, we do want to just start at a different position. Okay, so if it didn't do it didn't execute the if statement because we're not at 5, we're still at 0. At that position, okay. We're gonna add, so again, we'll just check just to do it again. So it then added to the register, back to the program select. Now we will jump to label 10, back up here again. So again, if statement didn't execute, run through the positions, add another one to the register. So now we're at data point of 2. Again, should be at a data point of 3, 4. Let's just verify. Yep, so we're at 4. Again. Now, we should be at 5. So we're gonna jump back up to the top, label 10, hit this statement. It's gonna jump down to label 20. Now we're gonna execute pick 2. So we just executed pick 1 5 times. Maybe I'll use a little bit more of an example. This could, with the logic that we have now, this would not be the case. But if you had 5 things to pick up, and then you need to move to another station to pick up 5 more things, that's where you would do this type of math. Okay, and then, so then we're just gonna execute the same code, right? The same code is gonna execute. I don't even know, yeah, so the robot can't reach those positions. Again, I haven't recorded positions, so matter of fact, I'll just do like this. Function, one abort all, and then I'll say touch up. Set new ID, no. Shift buttons on, no. So whenever it said, do you want me to set a new ID? What it's gonna do is it's gonna try to steal that number 1 and put it into this position. But I said, no, I don't want you to, I know this is already a position. I want you to give me another position with the same data. Same thing we'll do for this one, but I'll come up here just to shift forward. Now we're at that position. Now I'll come down here to the pick 2, and I'll say shift. Record. Shift, or touch up. I'll hit touch up. I'll do shift and then touch up. Now we're at that position. And see, I'll just go into another example of like copy and pasting and doing all this real quick. Maybe like now that we did what we did, let's just say, for instance, I want to do, what's an easy number? Like, I'll just do negative 1500, okay? Which will take us like 400 millimeters over. So negative 1500, enter. Oh, I didn't hit done. Gotta hit that done button. Position, oh, it took it somehow. Maybe because I pressed the enter button on my keyboard. Position, negative 1500, enter. Yeah, I think it is accepted. Done. Let me check it one more time just to make sure it's got the data, okay? And then you'll see this data is the same because position 3 and position 3 are the same positions. So if I click position, you'll see it's already a negative 1500. Now, if I kind of move my teach pennant out of the way and I zoom back, you can see where it just created these other new positions. Okay? Now, in the real world, let's say for instance I wanted this to be pickup number 2. Okay? I can adjust these again. You know, maybe let's just do that real quick. Position, give us some more real world. Let's say negative 1000, just see how it looks. Too far. Go negative 1100. Nice thing about Roboguide is you can just like punch in random numbers until you get something that you like, and just you can see the data change. If I didn't have Roboguide and I couldn't just visually see this, I would maybe even measure it. with the actual measuring tape or something like that to know exactly how far I want to move over. So I probably need to go like 1300. Oh shit. 1300. We'll go. That's pretty close. I think we can live with that 1300. Done. I'll also do the same to this position. I'll modify it to 1300. Negative 1300. So this moved us in the positive direction because our negative number became, you know, larger. So boom, now we're like roughly in that same pickup position, right? So now you can see, like, whenever we jump down to label 20, what would happen is this robot, yeah. Actually, let's do it like this. I'll kind of execute it a little bit. No, it won't. Okay, whatever. I'll just execute it from here. Do you want to do that? Yeah, I want to do that. This is also where you'd cause a crash condition in the real world. So you gotta be careful like doing these type of things. But boom, the robot moved way over there to execute this pickup. Boom. So you picked up 5 of these. Now you're going over here, and I don't think our program has set to do anything. It will be stuck in this loop right here. This is what'll happen because it's gonna jump to label 10. Right? So actually, let me just shift forward. Do you want to? I'm gonna just take off where you told me to take off. Shift forward, jump to label 10. Now we're back at the very top of our program, but we're gonna get down to this if statement and we're still equal to 5. So it's gonna send me back down to label 20. Now, the thing with this program, that's a bug, let's say, we'll continue to pick. We'll never stop picking from right here. Because there's nothing adding, we're not doing anything. We're just going up there, we're jumping back down here, running through this code, jumping back up there.
So can you put a subtraction like 23?
Yeah, we can do something like that. So let's say, let's go ahead and try to, let's follow our same programming method. What I mean by that, let's say I use pick 1, so I use register number 1, okay? And I have this if statement that says like this, and I have this one that says like this, okay? This math, right?
I want to put like pick 11.
So I use pick 1 there, so I use pick 2 here.
Oh, pick 2. Okay.
Yep. So like then like the most proper way that we could do something. When I say most proper way, I'm saying just in the numbering of things. So register, let's go ahead and use register 2. So let's go back to select. Now you can do one or two things. Like a lot of times if I'm doing the programming, I'm gonna just copy the instructions up here and then just modify the things inside of it. But just kind of for more like training sake, I'll just run through the instructions on adding these things. Again, I'm about to add an instruction here, there's not enough space. So I wanna add some lines. I'll add about 3 lines. I think I need 2 lines. Okay, so here, and then we'll say instruction, and then this should be an if statement up here at the top. And we say, I'm gonna do that same if statement. So I just said if register equals 5. So I'm gonna do the exact same thing, but I'm gonna use this other if statement. So when I was saying like there's more options, this list right here is larger as well. So this is the input side of things. You can look at a lot of different things here that you couldn't look at with the other other style if statement. Okay. So let's go register. Let's go, we're gonna use 2 because this is pick 2. 2, if register 2. See, now you had to build it. This is what I was saying when you had to build it. Now we need to insert something else. So if register 2, see I can make an and. So I can say if register 2 and 3 equals something, do this thing. So this is why I like these, because you can build them out like exactly how you want them to be. This one's just simple. I just use this example just to use this example. If register blah, 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 is equal to, we still want to equal to a constant, so the exact same thing. If register 2 is equal to a constant of 5, we use the same value as we did before because we have 5 parts we want to pick up. Jump to label. This one I'll make 11. Jump to label 11. So what I'm going to do is I'm going to put this right under here. Okay. Edit command. Oh, not edit command. Instruction. I do that all the time. Label first. So we need to do the label 11 that I just created. Okay. Now, one of the next things that I'm going to do here is I'm doing something prior to, because I know our code's going to cause a problem here in a minute. So I'm going to add something that's going to handle a condition that's going to create a bug in our code. So I want to say register equal to equal, register. I want register 2 to be equal to a constant of 0. Okay? I then also want to do something similar down here. So whenever I come to label 20 and just say instruction, register, 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 register 1 equal to a constant 0. Okay, so I added these conditions because there was going to be a bug. What the bug was, after I got done executing my 5 times of code right here, we would jump back up to the top and this would have never resetted. So it would have been 5, it would have executed the code 1 time, it would have became 6, and then it would never equal to 5 again. Yep, so I put the 0 to zero it out. And so I let this one, pick 1, 0 out, register 2. And I'm not saying this is absolutely the best programming practice, I'm just saying like this is a way to, and let's say for instance if we had like 3, 4, 5 of these positions, then we may have to say set register 1 equal to 0, set register 3 equal to 0, set all the ones that are not this one. And so we also have not gotten to the point of adding, so we still need to put our math in there of our register values. We'll do like this, instruction, registers, we'll do the +1, register. So register 2 plus register 2 plus a constant of 1. Boom. Again, I don't really care for this space to be here. Add a command, 1, insert line, so insert a line. So now I'm gonna go shift forward and I'm gonna let the program take me back to wherever we was at and executing. Also, we might have errors in our code. We're about to jump to label. I think I'm gonna start over from the top because I don't want to make anything weird. That'll make things confusing. So then we'll also start up from the very top of the program as well. Shift forward, do you want to start at a new position? Yes. Shift forward. So all of our data is zeroed out. So if something, so this register 0, or the register 2 equal to 0, it's already equal to 0, so you're just shoving another 0 in it. Okay, move to position, again, do the math, jump to level 10, move to the position. So I'm just gonna kind of run it through. So it's kind of just running. At some point it's gonna make the decision, right? Whenever it gets to 5. And I think it might be this next one. So we did the math. So now it jumped. Now we're at pick 2. Okay. Oop. Now you just seen the robot moved over there. Main thing is what this robot's doing here now anyway. So that's forward. Okay. In place. Boom. We'll do some math. We're gonna jump to label 10 all the way to the very top of the program. So let's go. the easiest way to go around like just having this issue be fixed would be to incorporate this together. So if register 2 equals 5, then set this one to 0. So that would be the easiest thing to do. And so we can do that. And then I can also just get into a little bit of an explanation of a different type of instruction that is now in the FANUC robot. It's been there for quite a few years now, but whenever I first started programming, the instruction wasn't there. So I had to do some tricks like this. So what I'm doing now, I will say it was like an older method of going about how you have to do this. I'm just gonna make these look, just make it like the other one at the top. Okay, if register 2 equals constant of 5, do the thing. Now I'm showing off a perfect example. So if I'm not mistaken, go back, instruction, if equals instruction, if register 2 equals. Also, again, I would just copy and paste these if I was not just kind of going through the process of this. 5. So see, now there's an option here for me to do like this. Set something equal to. If I'm not mistaken, that if statement I just had up a second ago, I don't think this was an option there. So I could go back and verify, but I'm pretty positive it wasn't. It's not there as an option. So now we can set register 1 equal to a constant of 0. Okay. Now again, programming wise, if I take this if statement and move it underneath of this one, this code will never execute. So we have to make sure that we set this register 1 equal to a 0 first. Then we jump to the top. So if I take our program back down here to the bottom and I jump to the top to make our decision, we'll just do that. So remember, the last thing that happened was the robot ran 1 cycle and then it did not continue to pick up its other 5 like it should have. So jump to label. If register 1 equals 5, jump to label 20. Why'd that not happen? Oh, because I already reset it. We already reset it. Remember, we reset it too early as there was a bug in the code. So I'll just set it to a 5 because it was 5 before we reset it prematurely. Yeah, that way we don't have to run back through it all again. So then I'm going to move back up again. I'll actually go back down to the bottom again to where it actually would have executed some of its final things. Okay, so from here, we're at the bottom of that pick. We performed 1 pick operation, but then we did not perform the other 5 pick operations like we should have. So again, starting from here at the bottom, we'll jump up to the top. Now we will jump to label 20 again, as we should. Okay, we'll then execute past this. Now this won't execute because register 2 does not equal 5 yet because we have not performed our 5 picks. We only picked 1 time. So now we'll perform the second pick. We'll add. Okay. Whoa, what just happened there, man? The data got reset again. How'd that happen? Oh, troubleshooting logic off the live, man. Oh, we didn't delete.
1, 0.
Yep, we didn't delete that logic. So this is what you call a bug in your logic. So almost all bugs are like a human-made bug where something's programmed in there and either you forgot to delete something or it didn't perform the way that you thought it was going to perform. Okay, back to the bottom of this one again. Shift forward. You sure you want to start there? Yep. Boom, boom. we didn't reset our data again. Okay, go back to reset our data. So we need that to be a 5, because that's what it would have done if we didn't have our bug. By the way, just like being a good programmer is knowing stuff like this, so that way you can just go manually plug in the number, go back to your program, and execute the thing that you're actually trying to like trial and test. Because we already identified what the problem was. We don't need to go back through from the very beginning of the program. We'll just start from here. So again, it's gonna jump down to the bottom. Also, we're gonna have a bug here. We're gonna have to remove this register 0 and do the same if statement up here. Or actually, no, it won't do that because that other one's on the bottom. Okay, do the math. So also another thing that got messed up is our data here got messed up. So even though we've performed multiple picks, we just now started adding the data appropriately. By the way, one thing that's always important is to look at like the final pick. A lot of times that's what will be off. Sometimes you'll only pick 4 when you meant to pick 5, or you might pick 6 when you meant to pick 5. Sometimes the count will be off by 1, and so you might need to move like either where your math is at or where your if statement's at to match the exact number that you actually wanted to pick. Because there's some instances where you might have to make this count to 6 to get you the number 5 that you actually want in physical space. It's nice to match what you want in exact space, but it doesn't always happen that way. Again, so where our data is at. We're at a 3 for that one. So we'll just keep running through our program. Okay, should be at a 4. Boom, jump back down there again. Okay, should be at a 5 now. Okay, we're still gonna jump up to the top. It's still gonna jump back down there again. Now we're gonna set the register 1 equal to a 0. We're then going to jump back up to label 11. Okay. Now we went ahead and we set register 2 equal to 0. Now this is okay in this instance because this logic's only gonna keep us up here only. Versus the other logic at the bottom, we kept sending it back up to the top. So like one way to like think about this is jumping up to, so like this top part of this code is jumping up to the top, whereas I guess the other one's jumping up to the top too. But the second one also jumps out to the bottom. It jumps out of the bottom. And when I say out of, I mean this is a loop right here, right? And so we hit this if statement, we jump out of this one to the other loop down there. And you can say the same for the other one, like at the bottom of the code, you jump out of that loop to jump back into the top loop. But you do that every single time. Okay, yeah, that's fine. Boom. So now I'm actually just gonna go ahead and turn off our shift. I'm gonna lower our robot speed. I'm just gonna see what she does. Shift, forward. Oh, no, hold on one second. Take off the step mode. Oop. So now I think we have an infinite loop of just going back and forth between the two. So now it'll infinitely loop, pick up 5, pick up 5. Pick up 5, pick up 5. Pretty sick?
Yeah, man. I like that, man. Hell yeah. That's fucking dope.
Yeah, so we can kind of see this thing in action now. There you go. Now we're in an infinite loop. So from here, like we would, we would have a pick position or something like that, place position, or not another pick position. We'd have a place position. So maybe we want to pick up 5 of this one, pick up 5 of that one, and then go place. The other thing that we're not demonstrating here that we'll demonstrate in another one is that instead of picking this with this one tool, this robot has, and let me pause this robot so I can, this robot has 3 tools on it. Tool 1 here, tool 2 here, tool 3 here. Okay, so how we're just picking up 1, 1, 1. This exact type of program was what we actually utilized in this operation. But instead of doing all this under one tool, we changed the position of the tool. I'll just try to throw these in here real quick. I doubt it'll work appropriately. I think it's gonna throw a fit, if I'm not mistaken. So whenever we go to pick 2, I'm gonna set that to a different U tool. So first of all, shift coordinate to find out what tool we're currently in. Okay, so you see that right there. So right before our pick position, we're gonna add another instruction here, offset in frames, U tool number, and we'll take it to a constant of 2. So that'll be tool 2. Okay. I also need to do, I got my shift key on. I need to do the same thing up here. See again, I don't have my spaces like I like. We'll put our spaces there, insert 1, 2, boop. Okay. So then we'll also add a U tool to this pick 1, edit command, instruction. Gotta put this instruction above here. It's gonna be a offset frame, U tool number, and then constant of 1. So when we're picking with 1, we'll use 1. When we're picking with 2, we'll use 2. Actually, and so also one other thing I think we can check here is in Roboguide, shift coordinate 2. So see how I just shifted that to 2? See how that dot changed? So I go shift coordinate, I'll type in 3. Notice how the dot just changed over there? So I actually want to use 3 on this pick 2 because I feel like it'll just work out a little better. It may not work out better, but that's what we actually used in this actual program. So we did a pick of that one, and then we used the center one to pick this center piece right here. So pick 2. So I think I want to go shift forward, and we'll say no to this, and then we'll find out. And since it's a virtual space, we can just run this thing, and then first of all, we're still at the top. I made the mistake of shift coordinate. I left it in 3. It shouldn't have been left in 3. I should have put it back to 1 where I had it. You gotta be careful with stuff like that. It's a good thing like it faults out and says that's an invalid tool. Now the next thing that I have to actually do is I have to reteach these positions in tool 2. Right? I think so. We'll run it. But I'm pretty positive I'm about to go through and reteach those tools. Or reteach those positions to be the appropriate tool. Yeah, so U tool 2. All right, so I think we'll just go ahead and wrap it up here then. We'll get into these user tools and this invalid tool, frame number mismatch. There should be a way to use the appropriate shift coordinate 3. That's the whole point of a U tool, is being able to change your U tool and create that as a position.